Hello everyone, welcome to another presentation here. My name is Andrew and today we're going to be going through all things balance. Balance and balance assessment has been one of those things that really up until very recent times has not been easy for members of the everyday health and fitness community in terms of being able to assess their clients, assess their patients, the people that they've worked with, in terms of getting real, true objective measures. I mean, to be honest, it's just been that the equipment that has been required to be able to do it has simply been inaccessible until recent times. Of course, now as AxIT users or potential AxIT users in the future utilising your Stomp-IT Force Plates, there is a lot more that is available to us in terms of being able to collect objective measurements and objective data when it comes to balance and postural, sway postural assessments, things like that. Unfortunately for a lot of us though, it isn't something necessarily that we may have a lot of experience in, or it might be something where we need to catch up a bit and develop our skills, because probably weren't taught how to do this type of stuff in the tertiary institutes where we learned all that. So without further ado, what I would like to present to you is what we're calling balance assessment for beginners. So, keeping it pretty straightforward, pretty easy. And what I hope we'll be able to cover today is, I guess, some of those fundamentals and some of those basics to give you a really good starting point from which you can start to explore balance and center of pressure assessment with the people that you work with. So let's get into it. So in terms of our assessments, right, up until, recent times, these were probably what we were dealing with in terms of how we would go about assessing people's balance capacity, their proprioception, the way in which they can control themselves through space. A lot of it was probably mostly in that kind of subjective assessment realm. So, for the health professionals, we're probably familiar with tests, special tests like our Romberg testing type processes, basically looking at how a client, kind of stands, whether that be in a double leg stance, in a single leg stance, kind of assessing how they perform some of those movements. Some of you may be familiar with some of the testing batteries and protocols like the Berg balance scale, essentially a series of movements and tests that we perform, in which is like a rating scaled as to how they're performed, and we can kind of accumulate or look at the cumulative result of some of that. Certainly a lot of individuals would then be familiar with some of the other tests that are probably on the lower functioning scale, things like our timed up and go test, maybe 30-second sit to stand test, starting to put some objective numbers on some of those movements. And then finally, particularly in, I guess, recent times, people have started to look more at some dynamic kind of testing measures, particularly objective assessments alongside things like your Y balance test, particularly if you're familiar with like FMS kind of scoring and that type of thing. So a way in which we can start to put some objective measures on some movements, but once again, maybe not appropriate for every individual that we work with. So the point with this is that, this is really what we've kind of had up until this point, and there can be some reasons why that hasn't been necessarily the best option. For example, a lot of these tests are not necessarily super sensitive to changes in terms of results and things like that. There could be reasons why they may not be necessarily appropriate in kind of all cases, and it doesn't necessarily allow for good kind of I guess breakdown as to the different systems that are involved when it comes to balance and proprioception in terms of different results and things like that. So this is where, of course, for you as an AxIT user, or once again, as a potential AxIT user, your force plate can become a really useful new tool, a new weapon in your arsenal to be able to assess balance and proprioception. Before we get into that, though, and how you start to do that, it's probably a good thing to start and, once again, at the basics and what is it that we're actually measuring when we're using a force plate to measure and perform some of these balance tests. So force plates, of course, are designed to measure ground reaction force. vertical ground reaction force in most cases, and particularly, if you've been using them up until this point, you'll be familiar with that in the sense that you've been using them to measure things like jumping and landing and, maybe some isometric testing in terms of how much force is exerted down through the floor. The beauty of it, though, is because your force plate, like your Stomp-IT, is a multi-load cell force plate, what it allows for us to do is triangulate the position of the maximum ground reaction force in a static stance type test. So something like in this example, we're doing a tandem inline test. We're able to measure the position of that center of pressure or that postural sway as the person's standing there. Now, it's really important that we differentiate between center of pressure and what some people will be familiar with, which is the center of mass, right? Which is looking more at the average, kind of location of the body's mass in position. So this kind of accounts for things like, I guess, our height, our weight, our position in many ways, things like that. So what we're doing in a static stance or position is we're measuring the center of pressure, which is once again at the level of the ground, the vertical ground reaction forces that are involved. Now, what our body will do in a static stance or a static position is our center of pressure will be constantly adjusting to try and keep our center of mass, so once again, where our mass is located in our body in that static stance, within our base of support, which is really determinant on the position of our feet in most cases. That's what we're going to be dealing with. So, the center of pressure is constantly adjusting to keep ourselves upright and balanced in terms of keeping that center of mass within that base of support. And so measuring this can be really important because it's often, the center of pressure is very reactive to that. It's constantly twitching, it's constantly adjusting. And so there's been plenty of research that has shown that these type of assessments can be really useful in many different ways. So looking at things like, how does someone, or what is the capacity for someone to control their center of pressure with that base of support, within that center of mass in things like orthopedics, falls prevention, neurodegenerative rehab, and lots of different factors. So this is what we're looking at, right? And there's lots of different ways in which we can do that to give us more information. So in terms of that testing then, we have a few different options, right? And you'll notice this within your AxIT software and your AxIT app, that when you go into the balance section, there are some different types of balance tests, and they have different use cases and different scenarios. Basically, the main thing, though, that we're manipulating in that example is we're manipulating that base of support, okay? So, and as we can see from the example here, where we have these different tests, then we're changing the foot position and therefore then changing that base of support. So the first is our double leg test. As we can see, we have both feet standing on each individual force plate, left foot on the left force plate, right foot on the right force plate. And as we can see through there, what that creates is probably our largest base of support. Because of this, this is our easiest assessment to perform. And particularly if you're dealing with people from a lower functioning standpoint, or, kind of in the beginnings of challenging people from an assessment standpoint, this is where you're probably going to focus a lot of the testing on. So the easiest test to perform. From there, as we can see, then the next test in our progression is our what's called a quiet standing test. Now, this one is kind of a little bit unique in the sense that basically what you're doing is you're standing with both feet, so left and right foot, on the left force plate. The reason why we choose the left force plate is you have to, one has to be allocated as the one that gets or has this performance, the test performed on it. So, to keep it simple, it's just always the left one in this example. Now, the reason why we perform that is then that's a progression in terms of narrowing that base of support. So as you can see here, we go from a double leg stance where the feet are out a little bit wider to then a narrower stance, what's called the quiet standing. And once again, it just makes it a little bit more challenging. So you can use this as a manipulation to make the testing a little bit more difficult to perform. From there, then the next test that we perform is what's called a tandem or inline tandem test. As you can see here, in this example, what's happening is the left and right foot, in this case, are in a stance where the back leg, the toes of the back leg is up against the heel of the front leg. And so what we're creating here is, once again, an even narrower base of support. Now, this is a test that's been used in a few different settings, certainly used a lot in falls prevention. I believe it's been used within maybe concussion management, things like that as well. The key here is that we have a front leg and a back leg. And so, as we can see here, the orientation of the force plates here is that the left leg is the one that is in the front, and the front side is on the left force plate in this example. So always the front, in terms of that orientation, is the left side. Once again, the key here with your tandem testing is typically what you're going to be doing is you're going to be testing with the dominant leg as the front leg. In this example, that's typically where the research goes for a lot of your testing. That being said, though, you could potentially create some custom tests where you test in different orientations if you wanted to through there, but by default, the dominant leg will be the front leg or standing on the left force in this example. Finally, as we can see, the last test is the single leg balance test. Now, this will probably be your default for a lot of higher level or higher functioning individuals, particularly like your return to sport type testing and MSK type testing. However, it certainly can be used once again in falls prevention, higher functioning older adults and things like that. As you can see, the difference here being that we're testing a single leg on each plate. So in this case, the right leg on the right force plate, the left leg on the left force plate. And as you can see here, it has the smallest base of support when it comes to control of that. So it creates the highest amount of demand. So hopefully that gives you a bit of an idea on the what we're doing by adding these different tests in. We're creating different base of support environments which are progressive in terms of how we might challenge an individual. Typically, if someone is very low functioning and a higher falls risk, we will probably test them at the bigger base of support end of the scale, either with a double leg or quiet standing test. And if someone is higher functioning, then we're probably going to be testing them with a tandem or single leg test. But that's not the only thing that we can manipulate when it comes to our testing. What we can also start to do is we can start to manipulate the test in a series of different ways. And basically what these have been defined as different types of balance tests that challenge the different systems that are involved that make up balance, because balance is obviously a very multifactorial quality when it comes to movement and postural control and things like that. Before we get into that, though, we probably should just make sure that we clarify how things work. And this is a pretty reductionist way of looking at things. I'm sure there are people who have spent a lot of time looking at this that will be able to contribute a lot more to it. But just for the sake of keeping things simple, I've really tried to simplify the way in which balance might work in many respects. Basically, obviously, we have multiple systems that are providing sensory inputs in some way to the central nervous system to create a output from a motor command standpoint to adjust our, the contraction of muscles in terms of controlling, once again, our center of pressure to make sure that we stay within that base of support and our center of mass through it. Some of those different inputs are things like, obviously, our visual inputs. So our visual inputs will take information from our surroundings and our orientation in terms of space and provide a lot of information in terms of where we are and how we're orientated. Also, of course, from that as well, we have our vestibular system and the way in which that provides sensory inputs as to our orientation in space and how we are positioned, so that once again we can coordinate with how we are. We also have some other sensory inputs that come from, of course, our muscles and joints. Most of us would know this as those proprioceptive inputs that come from all the different tissues of our body to be able to describe, I guess, the length of muscles, the length of tendons, kind of, how they're positioned, joint orientation, joint positions, things like that. Of course, we have a lot of information that comes from those that can unfortunately be affected after injury or things like that too. And then finally, those somatosensory inputs as well. So we're talking about here sensory inputs from the cutaneous tissues, mechanoreceptors in the skin, things that are sensing changes in pressure, probably mostly in most upright stances, through the bottom of the feet, things like that. And once again, they're providing information. All of this obviously goes up into the central nervous system. It gets collated. The brain uses that information to kind of map out where we are and what we're doing. And subconsciously, our muscles are constantly adjusting and constantly firing to make sure that we stay upright and we stay mobile, of course. So this is like our standard, I guess, protocol, right? If all of these things are kind of working as they should be, which is eyes are open, obviously we can't really control our vestibular system or how our muscles and joints kind of work, but making sure that we're standing on a hard, stable surface, then this would be our standard balance protocol in terms of what we're assessing. So we're just assessing how that system kind of works. That being said, though, what we can then start to do is maybe manipulate some of those variables and see how that kind of affects things. So what you'll then find is that another variable or a way in which your balance assessments might be described is what's called a more proprioceptive demanding protocol. Essentially what's happening here is this is when we're performing our balance assessment with the eyes closed. So what we're removing is we're removing the visual component to our balance and our proprioceptive test in that respect. So we have our eyes open testing in your AxIT system, but you'll also have your eyes closed testing in there as well. As you can see, if we remove the input from one sensory system, like our visual system, which depending on the research that you read, often makes up around kind of 10% of the information that controls our balance and proprioception in space. The other elements often have to increase their workload or take up the slack, or there's an increased demand on that. So we have an increased demand on the vestibular, the muscle and joint proprioceptors, and the somatosensory receptors in terms of the information or how much of that information is relied upon in terms of our balance and proprioception. And typically what we'll find is obviously when we close our eyes and perform a balance type test, often there is some impairment. There will be a worsening of the result in terms of some of the metrics that we'll discuss in a moment. So certainly you will see that naturally. However, if there is an abnormally large impairment through there, potentially this is a vestibular issue, potentially this is a muscle and joint proprioceptive issue, or maybe a neuropathy or something that's affecting those somatosensory receptors. That is then meaning that the balance and the proprioception and the center of pressure is dramatically impaired in that respect. So this is what we call our more proprioceptive biased testing. From there as well, though, then what we can have is a more visual bias testing. Essentially what we're doing here now is we're keeping the eyes open, so the visual feed is still able to contribute. But this time what we're reducing is we're reducing the feedback from those somatosensory receptors. The way in which we do that is our standard balance and or our balance type assessment when we're standing on something like the balance pad or the air pad, which I'm sure everyone would be quite familiar with, not only just from an assessment standpoint, but potentially also as a training standpoint. And so what we're doing is, by having that soft, uneven surface, we reduce the amount of feedback that is coming from those somatosensory receptors, those cutaneous receptors, pressure receptors in the base of the feet, and we increase the demand from, once again, the visual, the vestibular, and the muscle and joint system. So in this case, if you had a client that had maybe a visual impairment, potentially that would dramatically affect these results. But once again, we're challenging particularly the vestibular and the muscle and joint proprioceptors in that case too. So also, in both of these examples, if you're dealing with someone who is post injury, as we know, in particularly muscle tears, ligament tears, any kind of soft tissue injury or joint injury, potentially what we lose is we lose some of that proprioceptive input from the joint or from the tissues in that sense too. So we're challenging that deliberately by removing some of the other sensory inputs. Finally, and this is probably more towards the later stages, what we can do is we can really double down on that as well. And this is what we would classify as more of a vestibular bias in that respect. So what we're doing here is we're standing on the AxIT pad or the balance pad. We've removed then some of the somatosensory receptor feedback in that sense. We've then also applying an eyes closed type technique. So therefore then the visual input is reduced a lot. And so the demand then, once again, on those muscle and joint proprioceptors and the vestibular input is really turned up to the max in that respect. And so this is where then, particularly for your MSK type clients, where once again we're really focusing on the muscle and joint proprioceptors and how they perform. Potentially, if it's a return to sport type case, and there's little risk, then we're looking at comparing these left side versus right side. This is where we can really focus in on that. So kind of thinking of those lower limb return to sport type cases, this is where you're going to really be able to tease out whether or not there are some proprioceptive issues that need to be addressed before that client can return to sport. So kind of keeping that in mind in terms of those kind of progressions through them. So there you have it. That's kind of looking at, I guess, some of the different techniques that we can employ. Of course, if you're looking to then add these kind of tests in, you can create these as custom tests within your AxIT software. The AxIT software, as it stands, comes with the different types of tests. So manipulating the base of support. You then have different time frames from which you can test it on, and then we include the eyes open and eyes closed protocols. You may just need to, if you'd like to do so with, the balance pad or the AxIT pad or whatever it might be, you would just need to create that as a custom test to add that to your protocol, so that you can tag it appropriately. So just keep that in mind. So that's looking at the tests. Now about the metrics that will be generated from that. So after you perform a balance test using your Stomp-IT Force Plate, you are going to see 3 key metrics that are going to be generated on each test every single time that you perform them. The first of these key metrics is what's called your total excursion. So what we're looking at here is we're looking at the total excursion of the center of pressure force plate that's being drawn as the person is standing and performing the balance test that you perform. And so essentially what it is if we were to take the force trace there, the squiggle that gets drawn like so, if we were to take that, or imagine that to be a piece of string, if we took both ends of that and stretched it right out, how far or how long would that piece of string be? So pretty simple, pretty easy to understand. Obviously, it then stands to be true that, if we're comparing people on the same test, probably the person that has the longer total excursion distance is probably the person that has the least amount of control of their center of pressure and their postural site, in that sense. Now, one of the things that we need to consider with that, though, is that center of pressure is very reliant on the duration of the test. So you'll notice in your AxIT system that you have, a 15, a 30, and a 60-second test. It would be pretty difficult for someone, to score less on a 60-second test than they would on a 15-second test, because the duration is the thing that will really define a lot of that. So just keep that in mind with a lot of your testing there. Now, in terms of results, what we'll find in the research is, particularly you'll probably see a name quite a lot when it comes to balance research. This is Mr. Goebel here, has done a lot of research in balance. And what we see when we look to all of that is that there will be different durations of testing that you might see in the research, which will obviously lead to those different excursion distances and things like that. So we have some research here, though, from 2019, where a good sample size of kind of young adults were tested, and as you can see through here, across those different protocols that we've mentioned before, that standard, that proprioceptive, the visual protocol, and the vestibular protocol, and as you can see through here, pretty much across the board, there's fairly consistent, progression progression of the impairment, I guess, as we kind of go through those. The standard protocol tends to be the easiest one to perform and gets the lowest results when it comes to a total excursion. The proprioceptive result, that is with the eyes closed but still standing on the firm surface, tends to then be the next best performing, followed by the eyes open but standing on the balance pad, and then finally, obviously, the most challenging being the vestibular option. That tends to be, if we're looking across the board here, it's probably close to maybe 4 or 5 times greater in terms of the total excursion compared to that original kind of standard type testing now. So it gives us something that we can potentially look at and potentially use in terms of our interpretation. So just keep that in mind when you're looking through some of the research there, that just making sure that if you're going to be comparing total excursion, you want to be comparing the same time frames as the ones that you can perform in AxIT. Now, what we can do, though, or what you'll also notice, is that there is another metric that is next to total excursion, which is looking at the center of pressure velocity. Now, the reason why this is really useful is, and you'll find that it tends to correlate directly, obviously, with the total excursion. The reason for this is that our center of pressure velocity is looking at that total excursion, but dividing it by the actual time, so that we get rather than a total excursion in centimeters, we get how many centimeters per second does the person average across that test. So the reason why this is really useful is that it provides a more standardized measure that we can actually start to compare across research. So if we go back to our previous example here, we can look at this, the total excursion here, but if we just take these numbers and divide them by 20, because it was a 20-second test, what we then have is a more comparable testing velocity, which we could compare across the 15-second test, the 30-second test, which is typically the standard, or a 60-second test, which is one of the next most common testing kind of variables. So it gives us something that's a bit more standardized that we can work with there. This can also be useful if you want to then compare the effect of different timeframes. So, for example, looking at, say, a short 15-second test versus something like a 60-second test, Obviously, the 60-second test being a little bit longer, there's probably more of an endurance component, particularly if you're dealing with an older or lower functioning individual where fatigue might be a factor through there. You can look at how that potentially degrades it, and we want to maybe rule out fatigue as a factor. We can compare that against the 60-second option. But as I said, the main thing is that it allows us probably to compare more against some of the research and compare across a wide range of different tests. So when they've done that across the board, what we can see here is, like, for example, with those quiet standing tests, once again, this is research by Goebel, we can see that, those younger, fitter, healthier individuals are probably averaging on a quiet standing test, this is, 2 feet together on that one force plate or so, they're averaging, kind of close to 1 to 1.5 centimeters per second, whilst your fit and healthy older individuals are, considerably more, 2 to 2.5 centimeters per second. So it gives us something that we can kind of compare a bit easier for your clients and the people that we work with. The other thing that's great about that is then, there are some other great pieces of research where we've kind of looked at that in more athletic individuals as well. So, for example, here, this is a piece of research by Trajkovic from 2021, where they assessed a large proportion of athletes, these were national level athletes, across a range of different disciplines. And as you can see here, there was, once again, considerable difference across those athletes in a single leg, 30-second eyes open assessment. The dancers and the martial artists who, I guess typically we would consider to have high capacity for balance within their sport and their athleticism, performed better than, some of the athletes like the alpine skiers, who I guess, are typically kind of locked into a rigid boot. So probably have less demands for actual kind of balance and control through their foot and ankle joint in comparison to those other athletes. So once again, some good baselines here that you could use to compare with your athletes and, kind of give you some things to work with there. So particularly if you're working with basketballers, dancers, soccer players, track and field, volleyball, alpine skiing, tennis, martial arts, or speed skating, these might be good ones to use, but there's plenty more evidence out there as well. Finally, what you'll notice is that we have a final metric in there, which is called the confidence area metric. Now, this metric is really interesting because the last two were really quite raw metrics of just the total distance of the force trace and how far it traveled, and obviously further tends to mean less quality in terms of the balance and the control of center of pressure. This metric is looking a lot more at the quality or the shape of how that force trace has moved. What we're doing here is we're basically drawing a circle around 95% of the data points that make up that force trace. So as you can see from the image here, the left-hand side, the purple force trace here is obviously a lot bigger and a lot broader compared to the right-hand side that is a lot narrower and smaller. So if we were to try and draw a circle that covers 95% of those points, as you can see, the side on the left, the purple side, is a lot bigger than the side on the right, which is green. What we can then calculate from that is what is the surface area of that circle, okay? And so obviously the surface area of the left-hand side is going to be a lot bigger than the surface area of the right-hand side there. So this can be useful in many ways. Number one, it can be actually quite forgiving if there was, say, someone who was performing really well on a balance test, but then had like a sudden wobble or something like that. So say, someone who's very controlled, but then they suddenly lose their balance, they catch it and they come right back. Often this confidence area will probably ignore the, some of those data points that kind of shoot out and come back because it's only looking at the 95%. The other thing, though, that can be quite interesting, though, is you might have an individual who moves maybe very slowly, and um, you know, is kind of not necessarily generating a huge excursion because they're not kind of moving all over the place all the time, but maybe they're slowly, kind of moving their center of pressure in quite wide ranges through there. So really slow oscillations, which have had a little bit more of an impact in terms of like visual impairments and things like that. And so in that case, the center of pressure confidence area will pick that up because it's going to be mapping out that wide range in which the center of pressure force trace is moving across, a wider range there. So in general, look, the smaller the confidence area, the tighter the circle, the more control that person has over a tighter area in terms of maintaining their center of pressure. Once again, if you have like an MSK case where the person is having difficulty kind of controlling their overall movement, they're generally going to have a bigger confidence area in that. So just provides a little bit more qualitative information in terms of, how that force trace is presented. We can also use it a little bit in a like a qualitative standpoint to kind of look at the average kind of shape of the force trace as well. So, as you can see here, the force trace on the right-hand side, a little bit more orientated in an anterior-posterior direction, kind of suggests like the movement is a little bit more anterior-posterior, where the confidence area on the left-hand side, a little bit more mediolateral in terms of that. So potentially there is some qualitative information that can kind of guide where those deficiencies might be. Maybe that individual that is moving a lot more kind of mediolateral, maybe they need to work on some mediolateral kind of strengthening or something like that to be able to control themselves, and vice versa with the anterior posterior. So keep that in mind as well when you're looking at these kind of results, not just the number, but also looking at the shape of that force trace too. So we've covered now the different types of tests. We've covered now, some of those key metrics. What about like in terms of where this can be useful and, where you should be applying some of these balance assessments using your Stomp-IT Force Plates? When we look to the research, this is really becoming a lot more of a developing field. I mean, certainly there has been, some research that's been conducted over the last kind of 10 or so years, but I certainly feel like we're starting to see a lot more and more of this as force plates and the measurement of center of pressure becomes more and more accessible, of course, to researchers and looking at some of that. Of course, what you're going to probably use this case in a lot of is your lower limb MSK type cases, those return to sport, rehab type cases. And the classic one is, of course, that chronic ankle instability or CAI type clients. When we look to the research, certainly what we've seen is that, the center of pressure tends to be reduced during those kind of single leg or single limb static balance type tasks. So we want to obviously try and improve that. The easiest way to do this, of course, is to compare from side to side, non-affected side to affected side. But of course, if you've got that baseline data for the individual that you're working with, it can be really useful. Or once again, kind of comparing to some of those velocity measures that we've seen with some of those different kind of sporting types, this could be a really useful place to look at your center of pressure and your single leg balance assessments in particular. We've also seen that center of pressure or balance assessments can be really useful in particularly like falls prevention and falls risk. We're still probably yet to see some real kind of standards around, if someone is getting this number, they are a falls risk, and it's a hard and fast rule. But once again, I think we can kind of use some of that data, particularly around the velocity of the center of pressure to fit and healthy age-related norms to be able to kind of hopefully get most of our older clientele or maybe some of our neurologically affected clientele closer to where they should be based on their kind of age groups as well. We've seen as well, this is used in like mild cognitive impairment cases. So, you know, they have assessed different adults or older adult groups, control groups who are not affected, that mild cognitive impairment type group. And what they found was that those with a mild cognitive impairment often showed poorer center of pressure and postural control. Typically, in this case, they were looking at confidence area, and what they found was those with the MCI were around 25 to 45% worse off in terms of the confidence area metrics compared to that control group. And this was performed, you know, doing a standard quiet stand or double leg stance on both hard and soft surfaces with eyes open and eyes closed. They seemed to find that the results were more so more impacted by the softer surface, actually, rather than necessarily the eyes closed type intervention. And the thinking behind that is that, you know, with a mild cognitive impairment, you know, they're just slower to take up, you know, the relative sensory information to process that, to make those adjustments and center of pressure faster in many respects. So potentially there's an application. Of course, as well, center of pressure has been used in a range of neurodegenerative kind of assessments, often actually looking at more like the initiation of gait rather than kind of that static balance testing. But they certainly have seen it across the board with things like multiple sclerosis, Parkinson's disease, etc. That you know, it can be used maybe as a baseline assessment and then as a reassessment off the back of a you know, a balance and stability exercise intervention or strengthening intervention to try and improve, I guess, upright posture, balance and control. And certainly, you know, minimise things like falls prevention once again in those type of clients as well. So a really good baseline test that you can use as part of your assessments in those lower functioning individuals. One of the other things to consider, though, as well, is the time frame that you're selecting in terms of your testing. And this little graph here, I really wanted to show because I think it kind of highlights some of the importance of making sure that you choose enough of a capture time, I guess, to be able to collect the right amount of data. This was taken from a consensus that was performed by Scopper et al. In 2013, where they were, you know, doing a deep dive into some of the research and looking at, you know, what make appropriate criteria for a balance or center of pressure assessment. Now, what they basically found was that, as you can see, there's a lot of different kind of factors here that they were kind of considering across like multiple trials and things like that. As you can see, though, the convergence of the accuracy of those different factors really starts to come together around that 30-second. And so basically the recommendation from them in that study was that, you know, the best data comes from a test of at least 30 seconds or greater through those. So consider that. We include a shorter 15-second test in AxIT because we understand that time can just sometimes be a factor when it comes to our assessment. But realistically, the best research and the best results are going to come from at least a 30-second test. And the more, or if you can do longer, like a 60-second test, that will give you the best and most reproducible data in terms of those results. So consider that as part of it. So that's balance assessment on your force plate. Once again, it's probably just a very beginner kind of breakdown on what you're looking for, what do some of the test results mean, how you should consider some of your testing with some of the people that you work with. But also just to make sure, you know, your balance assessment is part of a a comprehensive physical profiling with the other tests that you can perform with AxIT or without AxIT. And it's all about collecting clues about what is going to have the most impact with the people that you work with. So, of course, balance and control, we're always going to be looking at other strength testing. Certainly, there has been plenty of research to suggest in our lower limb balance and control and controlling our center of pressure that strength deficits could be a big part of that, particularly around the foot and the ankle and the hip, which are big muscle groups for controlling our, positioning in space and particularly in those kind of anterior, posterior, medial, lateral direction. Often what they looked at with some of that as well is also not just the peak force in terms of strength, but that rate of force development too. Because the rate of force development is how quickly we can make those small little adjustments in our positioning and control that center of pressure. So don't just look at peak force in terms of your isometric testing when you're assessing foot and ankle and hip strength. Look at the rate of force development as well when it comes to that. Range of motion, particularly around the ankle, has also been shown to be a important determinant of body sway. So those with reduced range of motion at the foot and ankle, potentially don't control themselves as well. So there's plenty of different tests that you can do to look at foot and ankle range of motion type testing. Once again, looking for imbalances, looking for overall deficiencies. Consider as well applying some of those other tests that we mentioned at the start of the presentation alongside these, particularly with your older clientele. So, for example, that 30-second sit to stand, that timed up and go test, often these are assessing lots of different components, so things like range of motion, strength, just general confidence, well-being. But balance will be an important component of that. So particularly if you are assessing lower functioning individuals, maybe a static balance assessment to try and hone in on just the balance elements, and then looking at how that gets put together in something that's a little bit more dynamic might be a really useful way in which you can go about that as well. For the more athletic individuals, you would probably do something similar, but maybe a more dynamic balance and proprioceptive test as well. So, for example, that Y balance, excursion balance test, those examples are really great dynamic tests where we're looking at not only balance and proprioception, but we're looking at joint range of motion, muscle strength and control, potential endurance if you're doing lots of those kind of tests and other qualities too. So we can kind of combine the two of those to see maybe if there are similar discrepancies from side to side still in our athletes. We, certainly if they're returning to sport, we want to rule out that the static balance and proprioception is fine first before then maybe progressing them to those more dynamic tests as well. So consider that as part of it. Finally, particularly once again for your older individuals, don't forget your patient-reported outcome measures too. So specifically the activity-specific balance confidence scale, the ABC is what it's called, and the physical activity scale for the elderly, PACE. These were shown in a study by Nemers to have a real correlation, or the results of those and deficiencies on those was shown to have a real correlation with balance and stability in their research there. So, you may want to perform your physical outcome measures using your force plates with your elderly clientele in terms of their balance and their risk of falls. Make sure that they're progressing from a physical standpoint, but also consider those patient-reported outcome measures for more their subjective experience and how they're feeling about how things are progressing as well, and marrying those up are going to be important as part of any falls prevention program that you might be implementing with the people that you work with. So there you have it, guys. Hopefully that has given you a real beginner's understanding on where your balance assessment, measuring center of pressure can fit in using your AxIT Stomp-IT Force Plates with the people that you work with to help them feel better, move better, and perform better. As always, I'm Andrew. Thanks again for your time, and hoping that you will continue to help more people using AxIT.